Okay, so welcome everyone. This 3 hour session is basically for the training of Aviva System Platform 2023, specifically for this Diriyyadh Farms project. So I will try to make it quick and simple, directly related to the things that we are using in Diriyyadh Farms, not going into too much details. So let's first define the agenda for this training. Um, the name of the software is Aviva System Platform 2023, right? So as I shared with you the agenda, this training is divided into two separate parts. The part one that we are doing right now is introduction to system platform components and development methodology, right? And in part two, specifically, we will discuss um, the RIA farms, SCADA development standards, and integration techniques. Right. So starting with the first part. Okay. So let's start with before going on towards system platform, let's start with the core component that we are discussing right now, that is SCADA. So what basically is SCADA? In simple terms, the full form of the SCADA is supervisory control and data acquisition. So the main three components are listed in this full form: supervision, then control, and then the data acquisition. So what comes under supervision? We have, let me write it. Supervision means monitoring of assets. Assets means devices. For example, in field, we have a pump. So the core component, the core functionality of SCADA is we should monitor each and every critical component of pump and display it in the form of different values, different faceplates, different dashboards to the operator and management, right? So monitoring is the core asset or core component of SCADA. Second one is control. Apart from monitoring, the major difference between one of the major difference between HMI and SCADA is that in SCADA we actually give extensive control. But the control capability is not limited to specific equipment. We actually run it throughout the plant facility or any component or any area we are actually making the SCADA for. For example, in one of my projects in tunnel, we have jet fans, we have traffic lights, we have sensors, we have variable message signage. So instead of apart from giving control for each and every component separately, in SCADA we can design some response plans as well. For example, if in case of fire, abruptly using SCADA, using the capability of scripting in SCADA, we can give control commands to each and every component to work in unison and do one complete task in case of fire. So control of assets is second component, and the third and the most distinguishing feature of SCADA as compared to HMIs is data acquisition. By data acquisition, it means that each and every monitoring parameter and each and every control parameter which we actually require is logged into a database in SCADA, right? So what's the purpose of actually data logging? That in future we can use that data for multiple different reasons. The major reason is for historizing. For example, there was an event that occurred 1 month ago, and we need to generate some report or some kind of trend or some, you can say, root cause analysis, or we need to present to some management that at that specific time these were the sequence of events that occurred, and due to these reasons this is the outcome that happened at that specific time. So all the historical alarms and using the historical data that is available in our database, we can actually make statistical analysis, we can make predictive analysis, as well as we can do the maintenance related tasks using trends, using reporting, and using historical alarms and historical events. So the capability of historizing the data is one of the core components of SCADA as well. So storing of data in DB database. So if any software that is actually capable of doing these three basic tasks, we can call it as SCADA. So now introduction to system platform 2023. So why we call Aviva System Platform 2023 as a SCADA? Because it has all these three components within itself. And apart from these three, it has many others. So it is basically an extensive SCADA, not only a standalone SCADA, right? Now coming towards the development approach we use in System Platform 2023. Unlike other SCADAs in system platform, Aviva system platform, formerly it was called the Wonderware. So now the new name is Aviva system platform. The distinguishing feature of this system platform is that it uses OOP approach for development activities. By OOP, we means object-oriented programming. So what is basically OOP? It is a software language for developing different softwares, and the same technique for development in the system platform they acquire from the OOP concepts. In OOP, we have different classes, and inside classes we have objects, and inside object we have object parameters, right? So using the OOP concepts in system platform, we have, let me write it down for you. We have templates. Templates, you can take it as classes, or you can call as parents, right? Within templates, we have objects, or in technical terms, in Aviva terms, we call these automation objects. And in OOP concept, you can call it whatever it is written here in the second line, objects, right? And the third one, within objects, we define our attributes. Attributes, or in your PLC terms, you can say your IO points or your parameters. So these attributes, what these refer to in object-oriented programming, object parameters. For example, we have around 1,000 pumps in one facility, in one pumping station. So in object-oriented approach, we will create one template for pump. And within that, from that template, this parent template, we will drive 1,000 pump objects. Okay. So now what's the benefit of using this approach? For example, we need to maintain the attributes in these 1,000 pump objects, and all these may be different, may be similar. First, we should consider the case when these are exactly same, and each pump has around 50 attributes, 50 parameters. So what we will do, we will define those 50 parameters in this template pump, and these 1,000 pump objects, which are basically, this is parent and these are children. So whatever we assign to this parent template, whatever parameter, whatever graphic, what type of faceplate, what type of components, what type of scripting we use in this parent template, it will automatically be transferred to these children. So these children actually inherit their properties directly from this parent. So we will define the 50 parameters, 50 attributes or parameters in parent, and these children will acquire directly these 50 attributes from parent. So what's the benefit of this one? For example, later on during our project execution, during our testing and commissioning, if we need to modify these parameters, we do not have to go into these 1,000 pumps and do anything. We will directly make the changes in the template, the parent one, and these children will automatically adjust themselves and will acquire everything newly again from this parent one. Secondly, if 500 of these pump objects are different and 500 have different attributes, even they can be derived from the same template. In that sense, there is a different approach. It is also a concept of OOP, object-oriented programming, but in system platform, we use one approach which is called options and choices, right? So what we do in options and choices, the main template, the parent is same. Parent is same, but in parent, we make two options. First option is for 50 attributes, and second option is for other, sorry, 25 attributes if total are 50 and 25 attributes, right? So then when we will drive 1,000 pump objects in the same way, from within the children that we have derived out of these pump templates, we will have two options visible in each and every pump object. So there are different techniques. We can use Excel, we can use some scripting, or we can use some other approaches available in system platform. We can assign 500 pumps with option 1 and other 500 with option 2. And that's all. Even in future, if we want to increase or decrease anything, we will not open these 500 pumps. We will directly open the parent template, this one, and we will just make the changes in the options. We can increase one attribute in option 1 or decrease one in option 2, and automatically these 1,000 pumps will adjust themselves accordingly. So this is the main benefit, to minimize the development time, to minimize actually our troubleshooting, and to have one coherent strategy for the development, and to minimize actually making changes in each and every object. So instead, only parent is to be made the changes. The parent is then logged and everything resides in the parents. Nothing is changed in the children. But we always have an option. If we need to make some changes in the children, we can do that anytime if the parent is not logged, right? So this was a brief introduction regarding the development approach in system platform. Now, fourth main concept is regarding the architecture approach. If you guys have any question, you can actually ask uh, anytime. Okay.
Okay.
Mm. So the architecture approach that system platform actually uses is called distributed architecture. These are all these that I'm discussing. These are regarding the development and design of SCADA. You may not encounter all of these concepts during your testing and commissioning activities in the RIA farms, but still, to give you some core concepts, I am starting with these, and then obviously we will go towards how to actually do the testing and commissioning. What is meant by distributed architecture? Um, in a virtualized environment, which we call VE or VSE, virtualized system environment, we have dedicated machines for each and every component of system platform. For example, the first and the most critical machine is called GR node. GR node is basically called the Galaxy repository. As evident from the name itself, it is the core database of our SCADA application, and it contains each and everything that we actually do during our development phase. Like the like in simple terms, Galaxy is your SCADA application, and repository is that SCADA application's database. Whatever we do during our development phase, the graphics development, the parent templates development, the derivation of objects, the parameters, attributes development, the screens, and the linking of graphics on screen, the OMI development. OMI is another core concept, the operations management interface, the front end of SCADA, the historian linking, each and everything, whatever configurational or development activities we do in SCADA, that is being stored in a database which is residing on this machine, this GR node, right? So without this GR node, our application cannot run at all. Like the development activity is required, necessary, and then after this thing is finished, then comes the other machine, the second most critical machine, which is called the application server. So once development is done in GR node, just to run this application, uh, we actually dedicate another machine with um, with higher CPU resources, with higher processor, with higher RAM, with higher storage, so that the things, the deployed objects, the deployed application can run smoothly. So once development is done in GR, we deploy objects in application server, right? So application server is too critical in the production or in any environment. You can say that if it goes down, even if your GR is running, your application will go down, because GR is just containing the database. It is not actually running any application. Once the operator is sitting there, he is sitting on the operating workstation, he is doing his O&M task. If application server shuts down, his application will go down, because the core component for running the application is application server. Once the services as well as the objects, the templates, the graphics, everything is deployed, it actually resides on the application server, not in GR node. If we want to do some changes, we will have to deploy the application again. Like for example, there is one template in which we add one more attribute. Once we that development activity still be done in this GR node, but once we do any changes, our application server will require redeployment. Although it will still be running in its previous phase, but for the new addition to be shown on operator workstation, it needs redeployment, right? So this is
It,
one of the
it's
most.
it's online
Yes.
deployment or offline deployment. I mean, the operating system will disconnect
No,
from
no,
the
no, no.
operation.
No, no, no. It is online deployment. Like if operator is sitting on his workstation, he is working, he will just receive a message that a new deployment is going on, but still his day-to-day functionality will not be affected. It will not take more than 10 or 15 minutes, maybe less than that. So during that phase, he will see his previous application running fine, everything data coming from the field is okay. But once the new application is deployed, a new message will appear that you can run the new deployed application. Then he will click on that message, and within 1 to 2 seconds, his new application will be visible to him.
Okay.
So there's no downtime during our deployment operations. Okay, so the next most critical machine is our IO server. So what's the functionality of IO server? Like we need to connect to different PLCs or controllers or different local SCADAs in our environment, in our facility. So this IO server acts as a middleware between our application server and the third party local server or the PLC or the controller. So IO server contains drivers for making communication with Aviva application server. So this is also one of the most critical machines in our environment, because if it goes down, this IO server, although our application will be deployed, our application will be visible to the operator, but the data that is coming, it is coming through the IO server. So if it goes down, the data is not like correctly visible to the operator. It may be showing some past data, or it will be showing some errors, or some warnings that data is not accurate as per this point of time, because the IO server is down, right? Uh, Let me design some flow chart for your understanding. Like in at the bottom, we have, for example, here's the text. You can directly write inside it. Mm, yes. So in the bottom, we have field devices. Okay. So from field devices, the data comes to PLC or controller, right? Or RTU, you can say.
I have one question. Please.
Yes.
Does the GR node application server and IO server run on the same system?
No. By distributed architecture, as it is evident here, this distributed architecture, it is very mandatory that all of these components, all of these nodes run on separate machines. So we have different options for this one. Either we can have separate hardware servers for all of these, or to save our resources, or to save the budget, what we do, we virtualized the main hardware machine. For example, we buy one hardware server with good resources, and we do software virtualization. We make VMs within that hardware server, right? So there should be separate machine, either hardware or either virtualized, for all of these nodes. But obviously, Bakar, it depends on the application we are doing and the client requirements as well. In some cases, I have also seen that there is one standalone application. By standalone, it means there is only all in one node. There is only one node. Within that, there is GR, there is application server, there is IO server. But it is only for the smaller level applications, local SCADAs. If we talk about the master SCADA and the one that you will see in the RIA farms, it is like a very high-end SCADA. So to minimize the downtime, to distribute the resources, to distribute the application and working and development, everything, it is very mandatory and advisable from Aviva that we actually make separate nodes, separate VMs for all of these hardware machines. Even we can have separate hardware,
Okay.
but it is advisable from the budget perspective that we do the virtualization. And
Okay.
okay, so from the field devices, the data comes to the PLC controller RTU. From PLC controller RTU, it goes to the local SCADA. From local SCADA, it is just a high level diagram, right? From local SCADA, uh, let me copy. From local SCADA, it goes to our IO server, right? So this is the first point of contact between outer third-party systems and our Aviva system platform environment. From IO server, the data goes to our application server, and from application server, the data goes to our operator workstation, right? And then the GR node GR node is on the sideline, not in this vertical hierarchy. It is on the sideline. It is GR node. It is giving the deployment related data to application server. For example, let's use this. Okay. And then yeah, this what it is upward trend. Okay. And then on the sidelines, we also have one more machine, very critical, that we will discuss right now, which is historian. So whatever data is coming from field devices, it goes to PLC controller. It actually does some logic or some tagging, monitoring, tagging related things, stores it or forwards it directly to the local SCADA or HMI. From local SCADA is goes to this. So this is our, let me do one thing. This whole thing is text box. So this is our Aveva system platform environment. Okay. So from here, it enters our Viva SP environment. It goes to the IO server. From IO server, the specific driver, like Modbus or SNMP, OPC UA, anything, even soft communication we can do using RESTful APIs or JSON. So it acquires the data and it does nothing. It just gets the data from the local SCADA and it forwards the data to the application server. From application server, the data is stored in historian for the required tags, which are historized, and then the required data is forwarded to the deployed application on the operator workstation. And then here the operator sitting actually sees and monitors everything and even controls everything. This one from the historian, it is two-way. Like first, the application server gives data to historian to be stored, and then whenever it is required on the operator workstation on any other application deployed within the Viva system platform environment, it fetches the data back from the historian. In historian, in simple word, the data is stored in the form of a table, SQL table. The database that is used in system platform is basically Microsoft SQL. So in the SQL table, the data is stored, and then when we want to fetch the data back, we give it the required parameters, the column name, the attribute name, the parameter name, the object name, and gives the data back to our application server. Right. So this is the basic architecture for our application, the distributed architecture that we discussed here. Right. So everything clear right now?
Yes.
If we update the data on the main SCADA, mean that there is an impact on the local SCADA also. It will
No,
also
no, no, no.
change it.
No. For local SCADA, it is totally separate from our master SCADA. This rectangle that I created, it is a separate environment. This local SCADA is totally separate. Yes, the local SCADA will be affected. Not local SCADA will be affected, but the field level devices will be affected if we have given the control functionality on our system platform environment and the operator sitting in this main SCADA room or anywhere using the operating workstation, the application, he actually turns the specific device on or off. Then that control command will reflect on the field devices here. But the local SCADA will not be changed. In simple terms, local SCADA can be anything. It does not matter that it should be system platform. It can be Siemens, it can be Schneider, it can be any other brand, it can be factory top Rockwell. So the system
Means we have to update it separately if we want any change in the system.
exactly that is separate from this Aviva environment. Aviva environment is just doing two, three major things that we discussed at the start of this training. It is monitoring the data from any, it can be anywhere, not only from local SCADA. We can directly take the data from PLC as well. So it is just monitoring the data, whatever is coming from the outer world, the third party system. It is giving control commands and it is doing the data acquisition, which is the historization. And then from the historian, we can generate different things. We can do the SAP activities, we can do the ERPs, the management level things, and then we can generate reports, operator level reports, we can generate management level reports, we can do costing, and we can do budget analysis, everything. We can do the risk analysis, the root cause analysis in case of any event. So all of these things are dependent on this historian. But the data which is coming to historian, it is actually following this path that I created here. Okay.
Okay.
But the answer to your question is it will not affect local SCADA. Local SCADA is totally independent of our Aviva system platform.
It's mean that we are getting data directly from the PLC.
No, it actually depends. Usually, what happens, we can see the data that we are getting. It does not depend on if we are using the local SCADA or we are using the PLC. It depends on the communication integration protocol we are using. For example, in some cases, like in King Salman Park tunnels, uh, we do not have any local SCADA. So we are using this PLC as a controller, and we are using the Modbus TCP to fetch data directly from PLC. But in another project, there was one Honeywell SCADA installed on site, and we were required to integrate directly to the Honeywell. So it doesn't matter that Honeywell is getting data from PLC, from RT, or from any other source. The main task of our deployment is to get the data directly from Honeywell SCADA. So in Honeywell, they created one driver for us that acts as a server, and our Aviva system platform acted as a client. And we use the SNMP, OPC UA, and some other integration protocols to fetch the data directly from their server, not from the controller PLC. If PLC goes off, the data will go off on their SCADA as well as on our SCADA. But if their SCADA goes off, our connection with them will cut off, even if PLC is on or not, because we are getting data directly from their SCADA, not from PLC. But obviously, it varies from like project to project.
Like in Diriyyadh Farm, how we get the data in Diriyyadh Farm?
Yes, yes, in the RIA farms, we do not have any local SCADA. Like the SCADA that we are developing, it is the main SCADA, only SCADA available there.
Yes.
So we are getting data directly from the PLCs, the Modicon driver we are using.
Okay.
Okay, but in future, if they are actually desiring to have another SCADA on top of this one, which is usually called the master SCADA, then in that sense, it is always advisable to not go back to the same PLC, but already the data is integrated at one level, which is the local SCADA. So they will integrate the data from the local SCADA instead of going towards the field devices.
Okay.
Okay. So we have discussed in the same way. I have added some more machines in this architecture. So instead of writing here, we can just give the headings only. We have the historian. We discussed what is historian, its functionality, everything. Then we have the operator workstation, OWS. We then some other machines are also there, but that are not required right now. That are some core concepts of system platform. But just for the initial understanding of system platform, these few machines are just one machine. We have a licensing server as well. So all the licenses are separately installed and deployed in this server, and it distributes the licenses to every other machine, right? Every machine has its own license, GR node for development license, application server for deployment, IO server for communication, drivers license, historian for historian client and historian objects, and the time of historization license, everything. OWS for the front end license, which is called the supervisory client. So this licensing server actually includes all of these licenses. So we have a unified approach. All the licenses are maintained in one machine instead of distributing it everywhere. And then it will cause some management issues as well. So next, Let's go to the next topic, which is, what was the number? 4, 5, installation. All that is not required right now, but let me give you,
Usman bhai,
yeah.
the IO server, application server, and historian can be redundant as well, right? For the
Yeah,
three of them?
exactly. Exactly. It is very important. Thank you for asking this question. It is very important to maintain the standards for the high availability. High availability means that in case of any disruption, your application does not go up. There is no downtime. So it is always advisable for these three. IO server should be redundant, your application server should be redundant, and your historian should be redundant. GR node is not advisable to be redundant because if it goes off, it is not affecting our application. It is used only for development activities. And operator workstation is just front end, you can say the machine. It is not a server at all. So it is not required to be redundant as well. So these three should be redundant.
Okay.
Okay, now coming towards the installation. Let me, instead of writing anything here, let me check if I have the installation with me. Uh, yes, this one. Hmm. So if you open the folder that actually comes with the installation file, it includes the licensing related getting started guide, the system platform installation guide, the virtualization implementation guide, and the system platform getting started as well. So I shared with you this one, system platform getting started. It contains all the necessary information, the preliminary information for you to actually start getting to know this software. So let me open the setup. Okay, so right now in my machine, I have already installed. So it is giving me three options: modify, repair, or remove. But if you are doing a fresh installation, it will not show this message. It will directly go to another screen. So let me go forward. Let me show you. Mm. So it will ask me to close a lot of applications. So let's don't go it in this way. Let me open the install guide. I will guide you from here. Go to the operating system sizing guidelines. Yes, this section you can actually refer to during your installation guide. Required installation order of additional products if required, and the common components that you need to install, everything. And let me go to the system. If you want to understand what type of system platform prerequisites should be installed, so the main prerequisite for Aviva system platform installation is SQL server, because without SQL we will not be able to have the storage in the database for any of its components. This SQL is required for mainly for three different machines. One for GR node, so that all your development related data is stored in your database. Secondly, for your application server, and the third one for your historian. Application server, it is not required actually, but for historian it is very critical because all your historized tags and their data is actually being stored in the database, right? So SQL is firstly installed, and then after SQL installation, you actually go towards the installing of components of a Viva system platform, right? Yes, this one is very critical. We have during the installation, we have two different types of selection for the installation. One is the product based. By product based, it means that what kind of component the product you are going to install. Is it only a runtime environment? Like if it is operating workstation machine, we will select only the runtime, PCS runtime. If it is application server, we will select the application server. It will automatically install the required components. If it is the development node, let me see if there is a development node. No, it is not written here, but in the options, it gives us an option for the development node. So for GR node machine, we will select the development node. For the application server, we will select the deployment node or application node. For historian, we will select this one, the historian. Only this selection is to be made. Rest of components, the required component, it will install automatically. For licensing server, it will give an option for licensing and will install all the required components. right? So it is pretty simple. It does not require any other extra documentation. You can just refer to this documentation. It will be available for you, like easy for you. So the product based and the second option is role based. In the role based, the same type of components will be listed in a different format. Like it will give you options. If you want to make this machine a historian, select out of these listed components whatever you want to choose. In the same way for application server for GR node as well. So it is pretty simple. You can refer to this documentation anytime. So next component,
So my the SQL server should be installed on all the three servers, right?
SQL server should be installed on GR node, very necessary. IO server,
Okay.
very necessary. Historian, very necessary. For application server, it is not required because application
Okay.
servers core components are only deployment related activities, not storage related activities. SQL is usually used where storage is required. For GR node, the storage is required because all our development activities are being stored in a database. Whatever we are doing, it is in the backend, it is being stored in a database. For historian, all the historized data is being stored. And on the IO server, if we want to maintain a log of all the communication drivers or all that data that is being pulled from any third party server, we can use this SQL as well. Moreover, like if we want to do some soft integrations like RESTful APIs, so in that case, SQL Server is required as well. So on these three machines, it is pretty much required.
Okay.
Okay, so the next one is licensing. The licensing component. In licensing, we have two major types. First one is perpetual license, and the second one is flex license. Right? So the difference between perpetual and flex is that the perpetual is a one-time subscription or one-time buying of a license, and it stays there permanently forever. For example, there is one application where it is pretty evident that there are 100 IO points, for example, and these IO points will not increase or decrease during our future activities. So we buy the perpetual license, we activate it, and it goes on forever for these 100 IO points. But there is another scenario. For example, there is one application where client actually wants to expand his SCADA after a few years or after a few months. In that case, it is advisable to use the flex license. Flex means flexible license. In in flexible license, the strict amount of the IO points is not limited. It is not for forever. It is subscription based methodology in which monthly or yearly we subscribe to specific IO points. For example, in the first year, the client is saying I will use only 1000 IO points. But in second year, I'm not sure if the points will increase or decrease. So for the first year, we pay the price for 1000 IO points. And then the next year, we evaluate our SCADA. We see that if instead of 1000, we have 2000 points, we can use the same license and upgrade it to 2000 IO points. Just like in iCloud, we have 100 GBs, 200 GBs, 500 GBs. Depending on our needs, we can monthly change our plan. First, we buy 200, then we go for 500, depending on the data utilization. In the same way. But the pros and cons is that perpetual license is usually less expensive and it gives us like an ease that one time we activate this license and then it goes on forever. For flexible license, the pros are that it is flexible. We can change it anytime. We can upgrade it, downgrade it. But the con is that it is a little bit more expensive than perpetual license, and we have to like do this upgradation and the deployment of license again in the license server. So it all depends on our needs and demands and the client requirements, right? And one more thing in the licensing, our license is always calculated on the basis of number of IO points, right? So the basic methodology for calculation of what type of license, not the type of license, how many IO points license we are going to utilize in our application. We have to be confirmed on the field side that how many IO points as listed in our IO list are present in this application, because this number of IO points directly affects our licensing cost as well. More IO points, more cost, right? And then after IO points, we go towards selection of the type of license we are going to use. It depends on the client requirements, right? So let me show you how license is activated. So once you install everything, and these folders with the name, starting with the name of Aviva appears. Aviva's simple folder, then there's documentation, GR Access Toolkit, you can leave it for now. GR Historian, Aviva Historian is there, System Monitor is there, System Platform. Let's go to this Aviva folder, and this is the Enterprise License Manager. Let me open it. Okay. I think for this one, I will share a photo with you. Right now, there are some access issues for the license server on this machine. I will have to use another user for this access. So it will disrupt our this training presentation as well. So I will share a screenshot and attach it in the MOMs as well. So no issues. Then now after discussion of these development methodologies, architecture, installation, and licensing, let's go directly to our development environment, the development software that we're going to utilize, which is Aviva System Platform. If we go here, this folder, Aviva System Platform, it contains two things: Aviva OMI Application Manager, which is for operators, the front end, and this Aviva System Platform ID. This is the software that we're going to use for our development activities and deployment activities. So I have already opened it here. So when you open this system platform ID, this is the first page that will appear. Here it is written Galaxis. As I discussed at the start of the meeting, Galaxy is basically the database of our application. So we can create new Galaxy, or we can open an existing Galaxy. For new Galaxy, we have different uh, draft templates already available to start with, like some default Galaxy, or a totally new Galaxy, blank Galaxy, in-touch based Galaxy, or reactor demo. Reactor demo is basically a predefined project they have given to actually start our activities. I already created one Galaxy, test underscore Galaxy here in the recent. Let me double click on it and it will open our Galaxy. Okay, so this is the main environment of our development system platform ID. So let me explain one by one whatever components we have in this one. The first and the foremost, you can see here at the bottom, we have three different views: model view, deployment view, and derivation view, right? This is the understanding of these different views is the main component of development in system platform ID. Let me first theoretically explain you. The number, yeah, 6, 7. First one is derivation view. Second one is model view. And third one is deployment view, right? So what is actually derivation view? So whatever we discussed in our discussion on object-oriented programming, that is actually the derivation view. For example, in derivation view, we have in derivation view we define the template. For example, pump. From template we derive automation objects, which are pump underscore 01, pump underscore 02, etc. And then within automation objects, we define attributes. For example, pump underscore 01 dot run underscore sts, etc. Okay, so this is derivation view. In simple words, derivation view gives us an understanding that how parent-child relationship is maintained in our application. How many templates are there? From each template, how many objects are derived? And within each object, we can do our parameters and further activities. Model view gives us an other view. These are only different views of our application. All the things that are in derivation view will be available in model view as well as deployment view. But actually, you can, in simple words, you can say the difference is in which side we are actually seeing that specific application. Are we seeing it from the derivation perspective? Our perspective is changed actually. In the derivation view, we are seeing it from the parent-child relationship. In model view, we are seeing it from the physical perspective as per the site condition. For example, let me give you an example for the model view. There is one plant facility, for example, Aramco facility. Within Aramco facility, we have pumping station, we have filtration plant, we have offices, we have, for example, any other building, waste treatment plant, for example, building. Okay. So in model view, we will actually see the application from the perspective of how our devices are distributed physically across the entire facility. For example, in this case, Aramco facility. So what we will do, let me give you an example. First, we will create one area. In model views, we define it using areas. First area will be Aramco. Within Aramco, we will assign 4 different areas. First area, filtration building will be the second area. In the same way, offices will be the third one. And fourth one will be the waste treatment, right? Now, from this perspective, for example, pump 1 resides in pumping station. Pump underscore 01 will lie here. Pump 02 will lie here. In offices, maybe there are CCTV cameras. So CCTV underscore 01 will lie here. And for example, some CO sensor is in fourth building. So CO underscore 01 will be here. So from derivation view, all of these pump 01, pump 02, pump 3, 4 will derive from the same template, which is pump. But when we go to model view, these will be distributed across different areas, not in the same area. It gives us the physical perspective as per the site conditions that although these pumps are exactly same, the same type of parent, but the work they are doing, it is under different facilities, under different buildings, right? So model view gives us this perspective. And deployment, the last deployment view, it gives us an internal view, how our application is deployed. As during our architecture discussion, we said that application is always deployed in application servers, right? So for example, we have app server underscore 01, then we have app server underscore 02, app server underscore 03. This deployment view will give us an understanding that this pump 01 is deployed on which application server. Is it deployed on app server 1, app server 2, or app server 3? For example, app server 1, within app servers, we have app engines. These are sub processes running. And within app engine, we can define directly our areas. We can deploy areas and we can deploy objects. For example, in our case, on app server 01, within app engine on app server 01, we can deploy pumping station, and within pumping station, we can deploy pump underscore 01, right? In the same way, on app server 02, we can deploy filtration building, and within filtration building, we can deploy pump 02. And same goes on for other areas. We can deploy offices, and within offices, we can deploy CCTV underscore 01, right? So that understanding of these three views is very necessary. Do you have any questions or any type of confusion regarding these three views?
No.
No? Okay. Everyone is okay. Yes, so Bilal is here with us as well. Hi Bilal, how are you?
Hi everyone, how are you? Hi Usman.
Mm, hi Bilal. So Bilal will basically guide us regarding the Diriyyadh Farms development. He has been doing it for a long time. So after a brief introduction, what I'm doing right now, Bilal will actually go through the
Yeah.
application and let us know.
Okay, thank you, Usman.
Welcome, Bilal.
So,
Okay. So Bilal, let me just close down this discussion so we can
right.
directly go to our three farms. So everyone is clear on this deployment model and derivation view. Then directly going to application, we have these are the three views. You can derive from here. For example, let me derive one object and template for you. In master user defined, this is the main template. Let me derive another template by the name of pump 01. Pump template. Okay. From pump template, let me derive a few pumps. Pump underscore 01. Let me derive one more. Now, this is the parent-child relationship I was talking about in derivation view. This is the main master template, user-defined, it is locked. We cannot make any changes. So it is always advisable to derive another template. For example, in this case, we have derived one other master template, which is master user-defined. From master user-defined, we derived our main object template, the first one, which is pump. From pump, there are two children derived, pump 01 and pump 02, right? Now, this parent-child relationship is visible in derivation view. Now, if we want to go to model view, first we have to derive one area. So in the same way, from the derivation view, we will derive some master area. And from master area, let me derive one template for Aramco facility. Okay. So within Aramco facility, I can derive my instances. All of these instances will relate directly to this Ramco 1. First, the main master one, Ramco. Then, for example, we have pumping station. And one more. Then we have filtration plant, for example, filtration station. Okay, so if I go to model view, you can see here in my plant area, I have this Aramco facility, right? So what I will do, and I have all the objects listed here, but this view is not giving me the kind of relationship we actually saw in the derivation view. No parent-child relationship is visible. So first, what I will do, I will assign the model view as per my site conditions. This Aramco, let me first unassign it out of plant area. This Aramco is the main facility. Within Aramco, we have filtration station. I will assign it. And we have pumping station as well, right? So Aramco main facility, within it, two different stations. And within filtration station, we have pump 01. And within pumping station, we have pump 02. Okay. So now, if you see here, this view gives us an understanding with respect to the objects, but in a different perspective. The Aramco facility main area, within Aramco, we have two different stations. The pump 01, although derived from the same parent, it is residing in filtration station, and pump 02, it is residing in pumping station. Right, so it can help later on in our acquiring of alarms as well. For example, if client says he needs to see only the alarms for filtration station only, we can acquire the alarms from here. For all the objects that are listed here in filtration station, all the alarms will be accumulated in this area filtration station. Okay, now coming towards the deployment view, the last one. For the deployment view, we have to create a few platforms. Right now, there is one platform with this black color. It means this is the default platform for this DR node. It is not usually used. If you want to create for one for app server, let me create one here. App server 01. App server underscore 02. Okay. As I discussed earlier, within app servers, we actually assign app engines. App engines are basically services, Windows services that are running inside that specific machine. This app server is basically a virtual or a hardware machine, and within that machine, we assign different cores for the processing, for the deployment, for the data integration of different objects. So those cores that are assigned that actually reside within these app engines. So let me create a few app engines. Okay, so let's go to the deployment view. Okay, right now, app server, no app engine, and app server 02, no app engine, because no app server app engine is assigned to this one. Let's directly assign to this. Okay, anyways, we can discuss it later on, but let me explain it using this DR node platform, unlimited app engine, because right now I'm using Flex license, which is demo based. So this platform has actually acquired the unlimited app engines, but for this one app engine, let me check why no app engines are there. Flex license, Flex licensing. That's something. Let me assign it to app engine and let me assign it to app engine as well. Okay, so you can see here we have platform. This view gives us an understanding how our application is being deployed. We have the main platform. Within platform, we have the app engine. Within app engine, we have different areas like filtration station, pumping station, or even we can assign this Aramco here as well. And within filtration station, we have the objects, right? So if I click on pump 01, go to derivation view. This view gives us how this pump is derived from its parent. If we go to deployment view, this view gives us how this pump is deployed on which specific app engine and which specific platform. And this model view gives us an understanding where this pump actually resides as per the actual site conditions. It resides in the filtration station within the Aramco facility, right? So these are the basic three views. Secondly, if you want to maintain some graphics, then in visualization, you can see here we have different folders. We can actually assign different layouts here. We can maintain our graphics, screens, facelets, everything here. View app namespaces we can use for any global attributes or parameters we are going to use, and external content here. So this is regarding the visualization. The templates that we are seeing that we developed in this derivation view, all of these templates will be visible here as well. The view app templates and system templates, right? All of these master templates are here, and some default templates for our application development are here as well. Assets, we have system templates, whatever we defined in our derivation with Ramco facility, device integration templates, the simulator template as well. So we can drive from these templates, we can drive our instances, which will directly be visible in our derivation view. Okay, so this is regarding our views of ID for graphic development and linking. I think it will be discussed during our Diriyyadh Farms discussion. You can actually see that. Device integration objects we use. Let me show you. There are different views here visible. Model. If by some mistake you close down these views, you can automatically open it from this view section. So there is one view of IO devices. If we click on it on the right side, this section will appear, and all your DI objects, device integration objects, will be visible here. Like we have simulator, we have test client, and it all depends on what type of communication protocol you are using. So that specific communication protocol device integration object you can derive from here. Let me show you. This, for example, if you're using OPC client communication, you can drive from OPC. If you're using another communication, you can drive the DI object from the DD suite link client. So everything is available here in this derivation view. If you want to fetch data directly from the SQL database, you can use this SQL data client, the template for derivation of objects. So, and all of these will be visible here within your DI objects. You will create one topic, and that topic will act as a scan uh, cycle for the fetching of data directly from the local server from the PLC. Whatever time period you define in the net scan cycle and topic, after that period, it will fetch the data. And then you will define addresses. One last thing before we go towards the Diriyyadh Farm. Another software that we use is this one, Operations Control Management Console, OCMC. Let me open it. So here, two, three major functionalities we can do here. If you want to take the backup of our Galaxy database, it can be taken from here. Right click and take the backup, or we can restore it from here as well. If we want to see how many integration drivers we have activated and the licensed drivers and what type of integration we are doing, we can directly go here. And right now there is only one gateway driver and one simulator. If you want to add more, you can open the installer, and directly from the installer, you can select the type of drivers you want to add in OCMC. Once the driver is defined here, you will, for example, let me go to OI gateway. You will do the, for example, for OPC UA, you will do all the configuration of the parameters, and you will fetch the data directly from the OPC UA server. In case of OPC DA, you can give the server node, server name, etc., and you can fetch the data directly. In the same way, if you go for Modbus SNMP, this some type of configurations you need to do here, and then you can directly connect it with the local server. So this will act as your IO server. The data will be available in your IO server. Then once the data is available in IO server, you can define your DI object here, define a topic, and connect it with the relevant driver you defined in your IO server, and your data will be available in your application server as well. Then you just need to actually link it to specific object or graphic or historian for data logging. And one last thing, for example, there is one object, for example, station. For example, there this pump 01. Once you deploy it, you will right click on it, and there is one option here, view an object viewer. That Bilal will show you as well. In the object viewer, without opening any graphic, you can directly monitor the current status of the attributes. Like what if the value of the attribute is correct or not, if the quality is bad, if we are getting the timestamp value, you can see when last time that value was updated. And like without actually going to your graphic application, you can see all the data and all the troubleshooting directly from this object viewer. It is very useful during your troubleshooting activities. And one more thing which is useful in your troubleshooting is this log viewer. This log viewer actually contains each and every warning, information, error. Each and every message will be displayed here. Even if you create one object or derive anything or assign anything on your SCADA in the system platform ID, it will be logged here. So it is very useful to actually see uh, if you want to have an understanding what type of error you are actually inquiring in your application in system platform ID. The warnings are visible in yellow, errors are in red, and information in white. So you can add some filters as well here, and you can add new filters from here. Show, hide, anything you can do on the basis of process ID, thread ID, log, flag, component, or message. So you can do anything here. It will help you in your troubleshooting. And then obviously platform manager. If we go to the platform manager, it will give us an understanding of how our application is deployed. Like within this test Galaxy, I have deployed one platform, which is the GR node. And within that template, that platform, we have one app engine running. So it gives us an idea that right now this app engine is running on scan, engine ID is true. And in the same way, if we go here, it gives us an idea that the platform is running as well. And within platform, app engine is running as well. So from here, you can actually have an idea if there is an issue with the app engine or the platform. So you need to do some troubleshooting for that. So that's pretty much for OCMC and for system platform ID. And then one last thing. This is the front end, this view app. This view app is basically the front end of our application. Within this view app, let me open it. So you can see here, here you can define your front end, how many panes you need, how many sliding bars, top, bottom, left, right you need. Within each pane, you can actually assign what type of graphic will be shown. Even you can assign what type of graphic will be shown in which specific pane at which specific area level. For example, on the left side, you can see the navigation. At the home page, this front end is showing this graphic. And if you go to assets, you can actually assign another graphic within the same pane. So it gives us an idea that how application flow is maintained. Like utilizing the same pane, we can display different kind of information depending on the area hierarchy we are on. For example, on the Aramco facility main homepage, we can show the dashboards for the Aramco for the whole facility. But once we go to the pumping station, we can, using the same pane, we can update the dashboards for pumping station only. And when we go to the pump one, we can use the pump one symbol or pump one faceplate to show in that pane. So this is just an understanding of how. So if this is the development environment, if you want to see the preview of this application, you can directly click on this one. It will open the preview for this whole application we have developed. Okay, so this is the application, default application they have. This is the navigation bar from assets. You can see here whatever we added in our area that is visible here. Aramco Enterprise Filtration Station. Anything. Map. Let's go to map. What is here in maps? It's here in graphics. Graphics. What is here in Aviva? So all of these you can actually explore in your free time. This is the alarm spin. This is trends. This is the content presenter. Okay. Everything you can see in your free time. So I think we have discussed most of the major components of system platform ID and the Viva system platform. Even OCMC we have discussed. So now I think, Bilal, you can take access of Anydesk and share the insights for the Diriyyadh Farms application. So we can directly understand the development
Thank you,
activities,
Usman.
the process.
Yes,
Yes.
I'll share it. Just a second. So is my screen visible to everyone?
Yes, it is visible.
So I'll just try to build up on what Usman has explained up till now, starting with the development standards followed
Just
in
one
the
second.
Diriyyadh Farms.
Just one
Yeah.
second. Sorry, Bilal.
Okay.
Shabeen, Wakar, Abdurrab, Jinsan, everyone is listening, or you are sleeping? You guys are sleeping.
No, we are listening.
And Abdurrab, you?
We are here. We are here.
Okay. Okay, Bilal, you can continue.
Perfect. Okay, so starting with the development standards followed in the Diriyyadh Farms. So basically, I'll just give you the overview of what the Diriyyadh Farms Galaxy consists of. So as explained by Usman, we have these three views: model view, which explains the facility hierarchy of Diriyyadh Farms. So basically, it consists of the areas And areas in this case are basically your lifting stations and uh, lifting stations for phase one and lifting stations for phase three. So we have these two areas defined in the model view. So all the stations which were in phase one are in this lifting stations area, and the lifting stations phase three consists of all those in the phase three part. So the derivation tab, it consists of all those templates, and inside those templates we have our childs, the instances. So for example, we have this template over here, PSX discrete. So inside this template, we have a derived template, a discrete common CE, and then we have a derived template. And in these derived templates, further, if we go down to on off device CE, we have a template for pumps, which is motor CE. So all pumps are basically over here for phase one lifting stations as well as for phase three. Similarly, for switches, we have a different template, and the strategy is followed in a similar way. So this is all the parent-child relationship which has been established. So moving on, we have after these instances, areas are there, and then we have this deployment view, which explains or which for which area would be the host of these areas. For example, if we see the properties of any area, you'll see uh, from which template it has been derived, and what is the host of this area. So in this, for specifically Diriyyadh Farms, we have only one app engine, which is App Engine GP001. It basically consists of all those areas inside it. So these are templates, instances, and areas. And apart from that, in the deployment view, uh, inside this server GR, we have this app engine. And inside this app engine, we have all those areas for phase one and phase three. So it's the single engine which deals with all the areas inside the area farms. So apart from that, if we see the graphics part, we have this is in the graphics tab. We have this graphics button over here, and these are the tool sets. If you see, so if we expand this, we'll have further tool sets over here. And if we drop down, we can see the graphics for each lifting station according to their name. So, for example, this is South A lifting station. So we have its graphic over here, and the pumps are placed, and we have given them the owning object over here. So basically, this owning object is our instance, which is defined in our uh, Galaxy inside the derivation tab. So this is regarding the graphics, and towards the view app, as explained by Usman, we have this hierarchy over here. If we go into the derivation tab, we can see view app over here. So if we drop down, we have a drive template of it, and this is the instance of it. So if we open it, you can see the areas hierarchy would be on the left side on the navigation. If you drop down the assets, you'll see lifting stations for phase one as well as lifting stations for phase three. So all these stations over here are basically the representation of those areas which you see which you have seen in the model view. So this is just a replication of those areas. Like for example, in this lifting stations, phase 3, you can see G11 is there. A second. Yeah, so G11, all those areas which were in the model view are here. So this is basically the overview of the Diriyyadh Farms.
Just Bilal, one thing. I
Yes.
think we missed the faceplate part. We can do one thing.
Okay.
We can link from the object to the graphic,
Yeah.
the
Hmm.
faceplate, and then one thing is also missing, that we missed the DI objects, how the communication is
Yeah,
established between.
I'm coming towards that. So basically, if you open this instance in the model view, it's inside this area as 55 pumps. You'll have uh, this screen opened. Okay. So inside the attributes tab, you'll see all the uh, all the content which has been linked along uh, with this template. So inside this, you'll see these objects are linked, and the template which has been used for the pumps for these lifting stations is this tab operator FP. You can open it from here and see that this is the faceplate which is being used for the pumps. Then you can go to the industrial graphic and edit symbol, and you can see all the custom properties which have been explained over here on the right side. These are all the attributes which have been linked with this faceplate, right? Okay, and these are different faceplates, which is one is for maintenance, one is for operator. So the symbols are there which have been used for maintenance, alarm, failure, interlocks. Different objects are there. All those objects basically which needs to be shown on the runtime, they are supposed to be linked with this template. So pumps icon is there, uh, which are needed. And moving on towards the device object data flow concept. So basically in the derivation tab, we have this template as OPC client, and inside this we have different instances of it. Okay. So what we have done for the Diriyyadh Farms is that for currently we are for phase 3, I'll just try to open and show you that this is one you can see it as an example, like lifting station phase 3. This is the OPC client object, and over here we have given the server node of it. This is the PLC. This is the basically IP of that simulator, and this is the server name. Yeah, giving gateway. And one more thing which is we need to give is the scan group. So scan group and server node and server name. These three information is given inside this OPC client object. And then this information is then called in this redundant DI object. This basically explains this basically represents the redundancy object. So for this, we use the OPC clients for a primary DI source. The data is if the data is coming from one of the OPC client objects or the other one, if we give both the names over here. So I just showed you that this OPC object name comes in the primary DI source, and the second one is in the backup DI source, and we follow the same scan group over here. So this will eventually reflect in the input source which we give in the addresses for the instances for the data to be fetched. So I'll just show you an example how we are retrieving the information. How we are retrieving the data from the field. So in this particular pump, for example, this one, we'll go to the attributes and we'll filter out. This is the filter icon. We'll filter out which of the features are IO only, right? So only the ones which needs to be which need to be coming from the field, we'll able to see those. So over here, if I show you one attribute which is IO enabled, and its input source is mentioned over here. So if you see the syntax of it, I'll just copy and show you on the notepad. The first phrase is representing that redundant integration object, device integration object, which I just showed you, this one. Okay. So this part represents this one, and the scan group is this one. So these two the set of information is coming from here. Then after this, we have this MCS underscore connection dot device group. So as Usman showed you that operation control management console, we go over here and we have our all the controllers of each lifting station over here. So inside this controller, if you see, we have the combination as MCS underscore connection. So if we go into the operations integration server manager and we expand that, we have our drivers over here, the gateway, and then in configuration, we have this MCS underscore connection, which is our OPC UA device group. So if we follow the hierarchy of it, you can see under MCS underscore connection, we have device group. And then after that, the address is being followed. This address is basically coming from uh, the OPC UA tag browser. And this OPC UA tag browser is open from here, browse OPC UA server. So when you click on it, you'll see a hierarchy of all the topics. So from that hierarchy, if you, for example, want to see uh, the lifting station S55, you'll see that you'll get an address like this STW, and when you add to list, you'll see an address like this, which will reflect the same address which was given in the input source. So like this, you are building the address inside it. Correct me, Usman, if I'm wrong.
No, Bilal, exactly fine. So let's make it a little bit interactive. Anyone has any question regarding whatever we have discussed right now, or everything is clear till now? Shabir, Wakar, everything is clear?
Can we make some example right now in this uh, platform? Means if we add any lifting station for the test purpose, and then we add the template and the instance.
Okay, we can do that. Bilal, do one thing just for one test. Add another lifting station object and just assign one input source address to it. So they can have an idea that if they want to add one more object to another template, how they can do that.
Okay, so if I want to add an object inside this pumps in the model view,
Mm.
I'll just, as Usman showed you that you'll go to
Uh,
the
yes,
template, in the template.
uh, Vakar, the simple technique that we use while development, it will be used here as well, whatever I explained.
Yeah,
First, we will go to the derivation view and
yeah, and then
we will
we'll
drive the template. If the template is not
instance,
already, yeah, if template
yeah,
is not
instance,
already there, we will drive the template. But in our case, in the RIA farms, most of the templates are already there because it is not a
yeah.
new development. Phase one, phase two is already done. So
So
from the template, we will drive one object. For example, in our case, as Bilal has derived pump test underscore 01. So the next step should be
yeah,
that this
so pump
object.
test is being made, and yeah, yes, Usman.
Yes, yes. So the next step should be that this object is assigned to a specific area where it is residing. For example, in our case, as Bilal was explaining, lifting station 55. So if a new pump is added to lifting station 55, it will be derived from the same pump template, and then that instance will be assigned to lifting station 55 area. So now Bilal has derived the pump test object. Now he will assign it to lifting station
It will
55.
take couple of minutes to
Yeah, no issues. So once it is assigned to the area, Bilal will open the object, and the next step should be to actually give the input source, accurate input source. So
yeah.
whatever steps he explained earlier, he will use the same. He will give first in the hierarchy. He will give the redundant dir object name dot its topic name dot controller name dot the controller subtype name, whatever it was, MCS connection underscore device group. And after device group, he will see from the OPC
So
UA
now it's
browser.
asking me which area it needs to be assigned. So I'll just we cannot actually drag it as well,
Yes.
and inside this we can wait a minute. Pump test this one. So inside this we need to assign it to S55. So we'll just sign it. It comes under this area now. Okay. So what we can do is that
Okay, one more thing, Bilal. Uh,
Mhm.
Vakar, actually, whatever you asked, the simplest answer is three-step process. First, if you need to add one thing, it will be derived from the main template. For
Yeah.
example, we are using pump as an example, so it will be derived from the pump. Once it is derived, it will be assigned to the specific area it is residing. For example, in our case, to lifting station 55. And
Mhm.
usually what happens in the deployment view, areas are already assigned to specific app engines. So usually we do not have to do anything in the deployment view. But if the area is new, it is unassigned, then in the third step, you will go to the deployment view and you will assign the area to specific app engine just for
Mhm.
your deployment purpose. So once these three activities are done, the fourth step, the most important one, you will open the object and you will see the input source and give the relevant input source address as Bilal will explain right now.
Yeah. So if you go to any input source, if you want to give any input source to any attribute, you will just go over here, for example, this one, and you'll just write it over here, the same syntax as I described it earlier. So this whole syntax will go over here, Apart from that, this name will change for each particular device. For pumps, for example, this was supposed to be for SP01, S55, SP01. For in this case, so it will be for pump test, right? And this part I showed you earlier is coming from the operation control. This one, operation control, management console. We have these are controllers, so LS50, S55. So this name is coming from here. Okay. And if you want to see the new created object properties, you can go over here and see that its host is S55 pumps and its area is as well as 55 pumps. So, and what this area belongs to, you can go to its properties and you can see that its host is App Engine GP001. So there is only one App Engine in the Diriyyadh Farms, and every object is residing inside this App Engine. First, areas will come, and then under the areas, there will be objects. Okay. So this is the input addressing of this. Basically, it is followed in 3 steps. First, we have the OPC client objects. I'll just reset the view. So in the derivation view, you can see we have this OPC client template, and under this template, we have a drive template OPC client GP, and inside this template, we have these instances. These are the OPC client objects. First step is this. We have to configure these OPC client objects first. We need to give the server node, the server name, and the scan group. That's it. Then the second thing is that we need to uh, uh, configure the redundant device integration object, the RDI. For that, we have this RDIO ls underscore phase 3. So inside this, you just need to give those OPC client object names for primary and for backup. And the scan group, it will appear automatically, whatever was inside those OPC client object, that scan group will appear over here if you click on the copy common scan groups. So this is the second part. And the third part is that this syntax, which was inside those input address. All right. And then if you want to see whether our communication is established or not established, so what you will do is that you will go to the object itself. First of all, we need to check whether our OPC client object has a connection status with quality good or no. So what you will do is that you will right click on it and you'll on the OPC client object and you'll open it in the object viewer. Okay. After it is opened, you'll click on it and you'll just type connection CONN. So you'll get the connection status over here. Okay. Just right click on it and add to watch, and you can see that the value is connected and the quality is good. If this quality is bad, if this value is disconnected, it means that your OPC client object isn't communicating with your uh, operation control management console with the topic which you are seeing over here. Okay. So it is unable to communicate with the operation control management console. So from here you can see that our communication is established, but this is the first step. Then you need to check whether our redundant object is also connected or not. In a similar way, you will go and right click on it and you'll see the connection status. If these two checks are fine, then you will go to your object, for example, in this case, pump, and you will check whether the quality is good or not. For example, this pump, and then you'll go into the object viewer of it, open it, and then you'll see the status of that particular attribute which you are trying to test. So in this case, you will just figure out that attribute. For example, this we have over here div CFGW. So this one. So it's showing me a value, and it's also showing the quality as good. So it means that our lifting station S55 SP01 pump 1 is showing a value, and its quality is good. And after this check has been uh, measured, then you can open the runtime and check how is it like operating, and how you can test it at the runtime from your view app, from the preview which I just showed you from here. You can click on preview, and you can just go to that lifting station and check how the data is showing up. So this is the data flow of it basically.
Yes,
Next,
thank you.
yeah.
Is there anything else, Bilal, we need to discuss?
I think we have covered it. If there are any questions, you can ask.
Mm. So, are there any questions?
What is that redundant DISO something like now? We put different path. Can you explain that?
Yes.
For DISOs.
Yes. Basically, RDI is nothing. The main source object which is actually connecting with the driver is DIO object, device integration object. But usually for the high availability, as I explained earlier in the presentation, we do the redundancy on the device integration object level as well. For example, if we have two separate IO servers and we want to get the data from two separate sources, so from our development perspective, to communicate the same object with two different IO servers, it is always advisable to use RDI. What RDI will do? On the base level, we will have two separate DI objects like Bilal has opened. This is
This will
lifting station.
have a separate IP, and this OPC client will have a separate IP if we have two different servers. Yes.
Yes, exactly. So if we have two different IO servers, OPC A will have the IP, the server node of first integration server or IO server, and OPC B will have the second one. So all of both of these OPC A and B will be communicating to the integration servers separate, residing on different VMs and fetching the data at all times. But what data we are getting on the runtime, it depends on our priority, the primary and the secondary one. The RDI, in RDI, we define the primary DI source and backup DI source. So in our case, that RDI will always try to fetch data directly from OPC A. But when OPC A goes down or the integration server one is down due to any reason, it will not give us any downtime. It will automatically within milliseconds or microseconds, it will shift the data to the backup DI source and our runtime will not be affected at all. So that is the significance of using RDI.
So in order to have less downtime, we use this.
Exactly. But even Shabin, if there is no client requirement, or if we do not actually require the RDI, we can directly link the DI object to our IO source. But in the RIA farms, they have enabled this redundancy, so we are using the RDI.
Yeah.
Okay. So in the real farms,
So-
we have a redundant server for IO server, application server, or
Yes, I think we have separate virtualized machines for each and every node, for GR node, for application server, for integration and IO server.
Yeah, over here, if you see in the deployment, we'll able to pick that. So we have AS1, AS2, two app servers are there redundant. Operator workstations are there, two operator workstations are there.
Yes, secondly, Shabin, it is quite evident that they have redundant iOS servers because if the IO servers are not separate, they would not use the
Mm.
RDI. Only
Yeah.
one DI object would be sufficient. So right now, application servers are redundant as well as their integration servers, IO servers are redundant. And GR
Otherwise, they
node,
would have only used the OPC client object. That's it. No RDI would be there.
exactly, exactly. And secondly, GR node is always single, like it is not required to have separate redundant GR nodes because even if one GR node goes down, it will not affect our
Mm.
application. It is only used for development purposes.
But one more thing I want to add, if for example, which I showed you that the direct referencing we give the input, we give the address inside the input source rather than going manually and doing it one by one for each attribute. What you can do is that you can just simply go to that particular pump object or any object which you want, which you are integrating it. You can just select all and then you can export it. If you have, for example, 50 pumps or multiple objects you want to give the addressing to, so you can export them in the form of CSV, and then you will open this sort of a file in Excel, right? And if you want to like make any changes over here, so the first step over here would be to open it uh, like this. You will go to the data. First, select the A column, that tag name column, and go to data and text two columns. Then you have select delimited option, and you'll see the data like this. But want to, it's already separated. So basically, you choose these two options, tab and comma. Then you click on next, and you'll see data like this. It will be in the column, like it will be displayed in this manner. So I'll show you where we were giving the addresses inside the input source. For example, this one. So these are all the input source addressing which we gave. You can just simply change over here any change you want to do and just click on save as, but make sure to save it as in the form of CSV comma delimited. Save as this file and then re-import it in the system platform from here. If you go to Galaxy, you go to import, and from CSV, it will ask you the file, and then you just click on the option skip. All right, in order to be like in order to skip any overlapping or any updating the existing instance, any properties of the existing attribute. So just click on the skip option and import. It will like minimize your work, right? So the effort will be minimized. This is one of the shortcuts we have. If you have multiple instances and you want to do a bulk work, so instead of going one by one, you can do it like this. Is there any confusion in this?
No. Can you, with that pump test example, can you like open one lifting station screen and like add one pump object and add its
Yeah, okay,
attributes, something
okay.
like that?
So if in the graphics we have, these are all the graphic screens. For example, I want to add any pump over here. So you will simply go to assets and you will just type pump test. Okay. There are two ways to add it. I'll show you. So if you, example, you just simply select the icon which is being used and drag it over here. All right. And if you click on the properties, its name will appear, right? And from the toolbox as well, if you go and just simply write the object name. But in this case, in this development, we are simply using the assets. So the way I just showed you that I went to assets and uh, wrote this object name. So all these objects which will appear over here, basically these are part of that template uh, of this instance. So for pump test, this is the instance, but everything which has been added inside the template will show up here. As I showed you, if you open the pump test object, you will get to see that all the content over here, this content over here, will simply show up over here, that which object you want to use for this particular instance. So you'll simply drag it, and your owning object will represent that what is the tag name over here which you are using, and simply place it. And then you click on save. Is it clear?
Yes. Okay.
So this was the like tags placement or object placement and assigning the tags. Okay. And okay. Anything else, Usman, apart from this?
No, I think we have covered the major concepts, including the development perspective of derivation, deployment, model view, then
Mhm.
the DI object assignment, RDA, input source assignment.
Yeah, one more
And
thing, interlogs. For interlogs, you give any description for if for the lifting stations, we are following these descriptions for the interlocks. So you can just simply add the description over here, and it will just come up on the runtime when you're uh, testing the pumps. Yeah.
Okay. What about alarms and all? If you want to add an alarm, uh,
Yeah,
like that.
for alarms, if you go over here, I think this is one of the alarms. So this is an attribute, and it has been checked. This box has been checked. This is a state alarm. So whenever this attribute will come true, and this will be shown as alarm in the alarm banner, or in the runtime. If you'll see, you'll get the alarm banner over there, and whenever this value will get true, you will be able to see it.
yes, one more thing,
You configure it
Shabin.
from here.
Yes, one more thing, Shabin. This state alarm, if configured, it will be the current alarm. Like whenever on the field, this tag is true, and this state alarm is configured to become alive on true. Like if you go down, Bilal, in the state alarm settings, we have state alarm priority. It defines what type of priority it is. Like it is critical, it is medium priority, or low priority. So if usually what we define 0 to 250 is critical, 251 to 500 is medium, and 501 to 750 is low priority, and 751 to 999 is lowest priority, which is usually events. So first we have to define the priority, then obviously alarm message. Alarm message is usually directly fetched from the description of that tag. But if we want to have some string, some written description, we can add that as well. Third one, active alarm state, where it is, I think, written true here. So it means whenever this tag is true in the field, it will generate an alarm. But in some cases, if on false we want to generate an alarm, this active alarm state is set to false, right? and then time deadband, like how much seconds, milliseconds the alarm should remain in the true condition or false condition in the active alarm state to actually recognize it as an alarm in our front end application in our historian as well. Secondly, this alarm will automatically go to historian as well. Like
Yeah.
currently, it will be visible on the runtime, but when it is acknowledged, it goes from the field as well. It is always available in historian, and you can fetch the data for that alarm from the historian. One more
You
thing.
can able
Yes,
to
one.
yeah, you can see
Yes,
the trends as well over there, and the historian client is over there. You can see all the past trends of that alarm.
exactly. And one more thing, if you want to manually historize the value of this specific tag apart from alarm, you can see on the left side of state alarm button, there is one history button. If you enable it, as right now it is enabled, its value will directly go to the historian as well, apart from the alarm condition. Whenever it goes from 0 to 1 or 1 to 0, if it is Boolean, it will be historized on the data change. So this is for historian. The first button is for IO. Whatever Bilal explained, it is for input source. We want to read the tag, read, write, or write only, and then
Yeah.
we have to write the input source. The bad value alarm on the right side of state alarm is only for the bad quality or the bad conditions. Whenever the quality goes bad, this alarm will trigger. It will not be triggered on true or false condition. It will trigger on the basis of the quality of this tag. And then statistics,
And
it is used for
this
some reporting.
yeah,
Yes,
this description basically explains what this attribute is, and the alarm message, it will show up in the alarm banner. What the message? This will be exact message. What if the alarm will be shown up?
exactly.
So
As alarm
yeah,
comment, this message will be visible in the alarms pane. And then the last one, the log change, the last button, the sixth button, it is used for actually logging is as an event. So right now, I don't know, this strategy is not good. Like they have historized it, this Boolean as well, then configured it as state alarm and then log change as well. But usually what happens, what strategy we use for alarms, we enable the state alarm. For configuring an attribute as an event, we enable the log change. And for historizing any analog value, for the enablement of reporting and the trending analytics, we use the history tab. Not all three are usually enabled in one attribute. But right now, this Diriyyadh Farm's development is done in this way. So we have followed the same.
and inside this faceplate, I just want to add that how we are calling these attributes inside this faceplate from this template in which this instance resides. So, for example, if you see uh, all, if you see all the custom properties over here, you'll see, for example, for remote, if you see, you have these attributes, right? Whenever these two attributes are true, you will get the remote. Okay. From just try to explain how. Usman, I just want to check the output.
Sorry, what thing?
Yeah, this output. So you have this reference over here as OP. And what is OP basically? You will see it from the custom properties. So OP has a tag which is devctl.st.op, me.devctl.st.op. So what me is representing is that from wherever this faceplate is, for example, it's in a particular template, it's added in that particular template. From that template, it's representing as me. From within that template, this attribute is called upon devctl.st.op. So if we see devctl.st.op, it's here. So this is being called, corresponds to the position determined by the set point. So
Yes.
This is
And
basically
exactly,
the calling
and
of the attribute in the faceplate.
exactly,
Yeah.
and in the runtime, this me will be replaced by the object name, the tag name of the object from where it is called. For example, it is being called from lifting station pump 01. The exact tag name will replace this me condition, and then this whole me dot will represent the attribute that is defined in that specific pump 01. So it will directly fetch the value as was visible in the object viewer. So this
Mm.
resolution is automatically done. But from our perspective, just to have a unified approach, not to define each and every object separate faceplate, we use me, and on the runtime, it automatically replaces the object tag name.
Yeah.
So, Shabin, now we have linked from the field side using DI object to our driver, from driver to here in OPC client, from OPC client to the attribute inside the object, and from object, we used one symbol and placed it on screen, and from screen, we used to open it for one faceplate, and the faceplate, the same value will be displayed, which actually Bilal showed you right now, the OP value, me dot OP underscore pump 01, whatever it was. So this is the whole flow of our application regarding the integration part. For the development part, we already explained using this derivation, deployment, and model view, right?
Yeah.
Yeah. And also once we do a change, how we save it, like it should reflect on the runtime.
Yes. So changes are of two different types. One are graphical changes. So if you want to make any graphical change, you can just open the graphic, do the changes, and save and close it. It will be saved in that graphic. But very important point that you asked, these changes will not be reflected in the runtime. For runtime reflection, you need to redeploy your runtime application to that specific node. For example, Bilal, can
Yeah.
you go down to the viewer application?
So what will happen is that whenever you make any change to any instance or template, it will show up like this, half like partially yellow and black. So what this means is that it requires to be deployed again to like have those changes have the effect on the in the runtime.
Hmm.
So
Exactly. One more thing, Bilal.
yeah.
Let me explain them what these boxes means.
Yes.
See, if the whole box is yellow, it means it is undeployed. Like this specific object or template. No, this deployment actually does not occur on template. It actually occurs on object level only. So this specific object or area is totally undeployed. It is residing only on the development environment. So it will not be visible to the runtime environment to the operators, right? When you have deployed, this yellow box will totally disappear. The fully deployed object will not show any kind of box on the top left. But if you have deployed the object and after deployment, you make some changes in the GR, but those changes reside only in the GR and are not deployed. The fresh changes are not deployed to the application server. Then this half partially yellow, partially black box will appear. It shows that some changes are still pending to be deployed to the application server. So these three conditions you can actually see anywhere in your application.
Mm.
Okay. So now simply from this perspective, you can see the yellow ones are totally undeployed. The yellow and partial black one is half deployed. So that means some changes were done in our application. So this view app is not fully available to the operator, the new one. So now, Bilal, what Bilal will do, in case you are sitting on the production environment, what you will do, you will right click on it, view app GP,
And
and
then
you
you
will,
will go to
uh,
deploy.
exactly, you
And
will
you'll
deploy.
just simply deploy it
Yes.
with all
So
these default
exactly.
checkboxes.
And for the deploy objects, usually we go with the default boxes, but let me explain what these means. For
Yeah.
example, for the deployed object, you want to skip already deployed one and only make the new changes, then you can go for the deployed changes. Only the changes will be deployed instead of
Mm.
deploying each and everything back again. And for redeploy, it will redeploy each and everything, even the ones the objects that were actually deployed from the start, but including the changes, the redeployment will initiate the same service level request for each and everything that was available in that object, including the graphic changes, including the attributes, parameters, scripting, each and everything. So it will take some time. So just to save our time, we actually go with this deploy changes option. And this on scan is always on, because on scan means it will directly fetch the value from the D object, start running the script and everything. So usually I advise you go with whatever default option it gives you.
Yeah.
So this is regarding the changes,
So
Shabin, that you asked.
one more thing, if by somehow if you are not able to see any data coming up on the runtime, so what one check you can do is that, as Usman explained earlier, you can just simply go to your operation control, management console, and just check your platform manager. Okay. Don't know why it is not opening up. Yeah, to this. Okay, so you can just go to your platform manager and check the status of your platform and engine. So this is the Galaxy. This is the repository, and inside this we have engines. So just check whether it is running on scan or it off scan. So mostly it is off scan. This is the reason that you are not able to see the data over there. So just there's one check. This was added as well, right?
Yes. So any other question?
Think we can
What about
finish
the
the session, right?
yeah, user logins and everything now for the engineer, operator?
Yes, Shabin, for that part, I think right now it is like not included in the basic training, but let me give you a brief introduction. Bilal, can you go to the Galaxy on the top left?
Yeah. So first, let me close
Yes,
instances.
because in our Diriyyadh Farms application, all the users and user rights are already configured. They will not ask us
User,
to create some new. So no, Bilal, go to the configure. Go to configure, and inside it, security. Click on this security. Yes, you can open read only, no issues. So here, exactly, Shabin, you can see we have the authentication mode. What type of authentication is required? Is it user-based, operating system user-based, or group-based, or Galaxy-based? And then if you select for one of these options, you can go to the security groups. Now you can go. Yeah, so here you will define what specific templates or objects are defined in what type of groups. Like for different objects, you can define different groups and define different security terms for that. So here only grouping is being done. Then the main part that you asked, it
this
is
is all
defined.
those, these are all the objects which are consisting inside this security group. These are all
Exactly,
from the Galaxy.
exactly. And then Bilal, if you go to roles and users. Yes. So here, Shabin, the administrator, engineer, guest, operator, everything is defined with different access level. Access level is defined in terms of integers, numbers. And from right side, you can allow any specific security role for specific permissions. Like administrator can do anything, but engineer will have some lesser
Yeah,
privileges. Guest or operator
it
will
is.
have more or less. Like if operator, if we go to operator, it will not like allow to open the SMC because it doesn't have anything to do with SMC for the
Yeah,
config.
so there
Even for
will be
operator,
no checkboxes.
exactly. Even for operator, we will not allow him to open the system platform ID for development changes. So this is the security. And then if we go to users, Bilal.
Yeah.
So here, as we have operating system based users, so these are all the operating system users already created in Windows operating system, directly fetched from there. And once we click a specific user, we can define what role is assigned to this user. And these roles are automatically being fetched from the previous tab, the roles one, right? So step by step, first we define the authentication mode, then we define the role, and then that role is mapped to a specific users. And then if we want to add some credentials, in the last tab, we can add the credentials as well,
Yeah.
right? So this is regarding
These
the
are
security.
access levels which we can use in like hiding any faceplate or any specific user specific protocols. So we can use these access levels inside our system platform, inside that graphic. So to
Exactly.
like allow or not allow that particular user to open a certain graphic or not, like this.
Exactly. So, but Shabin, it is a very like vast concept regarding the security permissions and how do we allow that in within our application. So right now, like from the training perspective of the RIA, it is not required right now because application is already there, users and groups are already created, and we just have to add one new object, area, instances, and DI objects, etc. Not the users and roles right now. But still, I gave you a little concept regarding the security feature.
Cut it short,
Yeah,
like
yeah.
our concern is just related to the creation of new instances and their assignments to the areas and the app engines, and towards the linking of those objects to their device integration objects, and how the input addressing is being done and how the data is being fetched from the operation control management console. So this is
Yes,
all together which we need to focus on
exactly.
particularly.
Yeah, like if there's a button and how can we put the access level, like which administrator engineer or like that's what I need to know.
Sorry,
Like
button for what?
on the faceplate, like if there is any button, how can we assign the access
No,
level
no, no,
for
no,
that button?
no. We will not assign the access level. Access level are predefined in this security feature. Then in the application, whatever user is logged in, automatically the whole application will act according to it. For example, if administrator has logged into the application, all the user rights in the application will be affected as per the administrator user rights, right? And if operator has logged in, the application will behave differently. Some features will be disabled, some will be enabled, and everything, right? So it depends on the type of user who has logged into the application. It is not like multiple users can log into the same application at one specific time.
Yes, yes. Like I know I was asking like if there is a button, how can we give which who can access that? Who can click on the button? That's what I was asking. Like on the button, how
Yes.
we configure that?
Okay. For that, you can add animations. Bilal, can you open any graphic? Let us show him regarding the button.
Yeah. So this is
So
one of the buttons, for example.
exactly, you can just double click on this water station. Yes,
Right.
here if you go to plus. So Shabin, here, if you see, we have multiple options for visualization and interaction. You can see in the interaction, there is one disable functionality. The first tab, disable. So if you want that whenever operator is logged in, this button should be disabled. We click on this, Bilal, click on it.
Mm.
And then in the Boolean, click on it. You can add me dot my view apps, right? My view app
We have dot
dot security
security. Yeah. Dot
dot access
uh,
level something, it should be something like that, logged in access level, right? This
logged in
logged in
access level
access level
e-
is equal to
is
equal to
equal to.
yes, so equal to whatever access level you are defining for administrator, operator, or anything. You can
For
add
example,
that,
this
and then you can actually disable it whenever that access level has logged in, right? Or you can enable it vice versa.
you write it in
No, it is
this
only
or
integer. No, without,
okay.
I think, quotes, it is simple integer. Double equal, add double equal.
Hmm.
Yes.
Like
Okay.
this.
So yes. So in this
So
way, whenever 9,000
hmm,
access level, which is admin, I think. So whenever admin
yeah,
is logged in, this condition is true, and it disable this button.
yeah. All right.
Okay, okay. And after each change, we just click on save, right? And then we deploy.
Yeah.
Here
Okay.
we-
Okay. And save, and then you deploy the view app again with the changes.
Okay.
I think it's time for
Juma break.
yeah.
Yes, so if you guys have any other question, you can actually always call upon me or Bilal anytime. So we will reply to your queries. But I advise you to go through this video again, this recording, and obviously the system platform getting started guide that I shared with you guys. And I will share that Word document as well that we prepared during this training. So in your free time, you can go through that. And if you have any type of query, you can actually catch up on me or Bilal,
Yeah.
right?
Okay, okay.
Okay, so I'm hoping that an initial understanding, basic understanding is developed for system platform today. And inshallah, if needed, during your testing and commissioning phase, if you face any type of issue, we can discuss again, inshallah.
Inshallah.
Okay, inshallah.
Okay, okay
Thank
then.
you very much. Thank you.
Thank you.
Okay.
Okay, thank you, Usman.
Thank you so much, guys.
Thank you.
Okay, bye bye.
Bye.
Bye.